I have managed to get my parametric functions working. So as I mentioned in the last video, I wanted to draw a circle by taking angles between 0 and 2 pi and generating the cosine of the angle to give us the x component of a point and the sine of the angle to give us a y component of a point. And I would multiply these by 50 in order to get a circle which has radius 50. And as you can see here, I've managed to get it working. So what was the problem? Was there any problem in the code? Well, no, the code was fine. I actually had a little problem here within the computer. And it was a very simple thing. So if we head into the CPU and then get into the control section, and right at the bottom of the control section, we have a output here. So this is the instruction register coming into the control section. And what we did for the floating point instructions is take off a separate connection. And within that separate connection, we actually did a test to find out whether we are actually running a floating point instruction or not. So when we drop in here, this was the little bit where there was a mistake. So we have to find the floating point instruction numbers. Okay, so the floating point instruction numbers actually come from the spreadsheet which I have here. I'll make it a little bit bigger, maybe see it a little bit better. So if I was to come down to these ones here, so this is fmult. So all of these are the floating point instructions. So multiply, add and subtract. And you can see they start off at 7c and they go all the way down here to this value here, which is 94. So it meant that I had to choose numbers between these two ranges. And if I put in the numbers between these two ranges, and if it came up both of them, so they're within those two ranges, the output would go high here, and it would tell us that we've actually got a floating point command that we're running. But the problem is here, I had this set at 7c00 and I had it greater than. So it meant that whenever the 7c00, which was the multiply command there, came in, it never recognised it. I should have had it greater than or equal to in order for it to work. But I've decided just to put in the greater than, and I've changed this rather than having 7c00, I've picked the one before, which is 7bff. Okay, so that's all it needed. It was something relatively straightforward, but sometimes it can take a little bit of time to work out exactly what is going on. So just a little offshoot of this, how I was able to find the error. Well, I ran through the code and I ran through it literally very slowly. So I put up simulate and I changed the tick frequency to a very low tick frequency, and I let it run through to a certain point in the code, and then I stopped it, and then I ran through the individual points here. Okay, so I was able to click this clock in, and it clocked each individual pulse all the way through the simulation. And I also, whenever I got to a point that I was interested in this instance here it was the fadd, then I looked at the microcode here for the fadd, which is in this column here. Again, I'll make it a little bit bigger in this sheet. So the microcode for the fadd was fmultiply was here. So I worked through these individual steps here within the microcode. And whenever I worked through here, I realised that at this point here, at point 7 here on this particular multiply addressing mode, that the actual circuit wasn't going live. Okay, so at no point did the floating point unit actually activate. Okay, so it meant that this line here, ALU-FPU, this point here, never got activated, and this was coming from here, again, which is inside the control section, which is this point here. Okay, and you can see it being activated now. Okay, now it was working for all of the other addressing modes. It was just that very first one that there was an error at. And I think what I've probably done is I've been messing about in here, and I was probably set at greater than and equal to, and I've got rid of this little line here by accident. So that's all. It's all working fine. It's actually, when you think about what's happening here, the circle looks pretty damn fine. Okay, it's generating a relatively good circle, considering we're running through a 16-bit floating point unit, and then we're approximating it using a simple nearest integer. So thank you for listening. That's all for this video. I'll get you on the next video. Goodbye.